In this video, we will explore whether instructors' teaching evaluations are influenced by their appearances or good looks. We will illustrate these analytics using IBM's Watson Analytics. A good place to start is watsonanalytics.com, which will bring you to this website. If you already have an account with Watson Analytics, you can sign in here. If not, you can register it for free. Since I have an account with Watson Analytics, I will sign in. Once I have signed in, my desktop looks like the following. You have several options. A good starting point is to bring my data into Watson Analytics, so I will be clicking on the Add button. As I click on the Add button, I see an option to upload data. I click on this, and then I click on Browse, which brings me to the place where I have my dataset, which is essentially a CSV file that I would bring in, and I click on Open, and Watson Analytics is going to transfer the data into its native data format. Once the data has been imported, you can see it in Watson Analytics, and one of the things you will see is that it will assign sort of the robustness of data set, how good it is in terms of missing values and whatnot. And here we get a statistical metric of 73. I think it ranges between 0 and 100, and it's a good quality or medium quality data set. We have two variables of interest. We are interested in the beauty score, and we are also interested in the evaluation or the teaching evaluation score. The teaching evaluation score ranges between 2 and 5, the minimum being 2 and the maximum being 5, whereas the beauty score has been normalized such that the average beauty score is 0. So some would have less than 0 or a negative beauty score, and others would have a greater than 0 or a positive beauty score. What we are interested in at this moment is to see how other interesting attributes of the individuals, their gender being one, and the professor's tenure status as being tenured or otherwise, is correlated with either beauty or evaluation. For this purpose, we will click on Explore to see how these relationships are so that we can visualize them. So we click on Teaching Ratings, and a new dialog box will appear. We're giving us the options. For example, some of the questions it's already trying to answer for what is the trend of all students over age by division and the like. But we are interested in the following question. Our question is, we want to see the beauty score by, let's say, the gender of the instructor and their tenure status. I just simply have written or typed beauty by gender and tenure, and then Watson Analytics intelligently poses the question, how do the values of beauty compare by gender and tenure? This is the exact question we wanted to ask, so I simply click on it. Here is the response. Now notice that we are looking at not the average of beauty score, but the total beauty score. So let's change that to average. So we double click on it and we say summarize it by average, and now we got the picture that we really wanted. We have the average beauty score on the y-axis and the instructor's gender on the x-axis. So here this blue bar tells us that these are the female instructors who are not tenured, and their average beauty score is 0.16, negative 0.16, and this green bar represents female instructors or professors who are tenured, and their average beauty score is 0.21. So from just by looking at, we see that tenured professors who are females got a better got a better beauty score than those who are non-tenured. Interestingly enough, we got a reverse or quite different trend for male professors. Those who were not tenured got a higher beauty score than those male professors who were tenured. Now let's compare the evaluation score by gender and tenure. To ask this new question, how evaluation changes by gender and tenure, I click on new and then say, how does teaching evaluation changes by gender and tenure? And here's the question which comes up right there. I click on it and I get the average evaluation score. So I know that this is an average and it's the teaching evaluation score, and then disaggregated by gender of the instructor, female and males here. You can see at the x-axis, and then whether they are tenured or untenured. You could see the highest teaching evaluation score is about 4.3 or something, 4.4 actually. You can see that is for male instructors who are non-tenured, and then on just eyeballing it, I could see that female instructors, whether tenured or otherwise, got lower teaching evaluation scores in this very sample of about 400 courses. The next step for us is to determine how teaching evaluations differ by gender and tenure and of course beauty. And for this, Watson Analytics will use a predict function. For this to happen, we click on Teaching Ratings Exploration, go back to the welcome screen and click on predict. We click on the data set, and as soon as we click on the data set, we get the visual display of data. We have to select a target. So our target in this case is the eval, or the teaching evaluation score. We click on this option, edit this workbook's field properties to subselect the variables of interest. You will notice that the data set contains several variables. We will restrict our data to only those 3 variables that we are interested in and unselect the others. So how do we do this? For example, all students, this is a variable we do not want, so we will select its role as none, and I will repeat the same for other variables. I have removed the following variables: the all students, credits, division, prof, and students from further consideration, and we'll be working with beauty, gender, minority status, native English language proficiency, and the tenure status of the individual instructors. Now that I have my data selected, I will click on continue, and once I click on continue, I will get the option to name this prediction as predict, and I will just call predict underscore eval and click on create. Now Watson Analytics is doing the number crunching behind the scenes for us. As soon as Watson Analytics is done doing the number crunching, we see the output as follows on the screen, and we would like to use the combination option to see how these variables, beauty, gender, and others, are correlated with our variable of interest, eval. Remember, we want to know if teaching evaluations are influenced by these factors. And one of the interesting things that Watson Analytics does for us is it applies the Chade algorithm to come up with a decision tree. And let's look at that decision tree to learn a little bit more about our model. We click on the visual display, and then it displays the tree for us. Notice that the first most important variable that it has found that has the biggest correlation with teaching evaluation is in fact beauty. And we see that the algorithm divides the instructors into those who got a lower than 0.68 teaching evaluation and their teaching 0.68 beauty score, and their teaching evaluation average was 3.8, and there were about 97 records in there. And then others who had a teaching evaluation or beauty score of greater than minus 0.68, and their teaching evaluation score was slightly higher at 4.05. Then we see the next break happening at gender, where males had an average teaching evaluation of 4.18 compared with females who had a lower teaching evaluation of 3.89. And finally, we look at the last break, which happens at tenure, whether instructors were tenured or otherwise, and we see, and let me just move the display, and I can actually zoom in and out of the display here, and I can remove this window as well, so you see that brief window is gone. Now I'm going back at tenure, and I'm just going to zoom in a little bit so that I can see better. And tenure has a split between non-tenured professors and tenured professors, and I can see that the average teaching evaluation for tenured professors is 4.1 compared to that of non-tenured professors who have the teaching evaluation score of 4.4. So right then and there I can see that instructors who are non-tenured male and whose teaching or beauty score is greater than 0.68, negative 0.68, have the highest teaching evaluation. So does beauty matter? Of course it does. In this particular case, Watson Analytics applied a smart algorithm called the JADE algorithm and gave us the answer. And if you want to see how the decision rules were applied, we can click on the top decision rules to say that those with a teaching beauty score of minus 0.68 or higher, male and untenured, had the highest teaching evaluation, and the lowest one was for the group that had the lower than minus 0.68 as their beauty score.